Hi, everybody. So this is an introduction to the chapter where they describe how data sets look. And I just wanted to give you sort of a bird's eye view of why they put this up front and why I'm having you use this right away. This actually is really important in public health, that you know how to open a publicly available data set and work with it. In order to emphasize how important that is, I'm going to page 12, and this is a description of how data is presented and in relation to 2 by 2 tables that you'll recognize from epidemiology. So here you have a view, what we call the data view. This is basically a small version of what it's going to look like when you do open SPSS, not until next week. So what you're going to see next week is you're going to click open and you're going to see something like what you see in that participant ID, but you're going to see that go all the way down several thousand rows. And then instead of just having 3 variables, you're going to have over 150 variables. So it's going to look fairly overwhelming, and they've broken it down for you so you know how to read that information. So the first thing is to say that very top row, those are names of variables. Participant ID, that is like a name. That is a way of saying that is this particular person. And we need to have an ID that is not related to or can't be linked back to that individual by somebody who doesn't have access to the data. So that if somebody with malicious intent happened to have access or hack into this data set, they still wouldn't know who that person is. So we de-identify by attaching a number instead of a name to a participant. And then the second variable is called treatment group, and that's where it's recorded. So you have 530 children. They were randomly allocated, about half and half, it should be, between the 2 different groups. One is the intervention, which was to give a therapy of 6 grams of peanuts with the idea that by the age of 5, they would be less likely to be allergic. That was the experiment, hopefully. That experiment works. You always want that to be the case. And usually you don't do an intervention like this until you have good information that you really, really strongly believe it's likely to bring benefit, the intervention is. So you have the peanut consumption group, the peanut avoidance group, and then you have a third variable which you record whether or not they passed the oral food challenge. In other words, did they become allergic at the end of the study? Now, this information, they don't give you the information for all 530 children. They just show you the first 5 individuals. The data from that study is then organized the way we do in epidemiology in a 2 by 2 table, or 2-way summary table is how they call it. And this is figure 1.3. And here they say, okay, we think that the group that didn't get the intervention is going to be the risk group. So we're going to put them first in the table. We're going to put them at the top. And we're going to compare our non-intervention group, the peanut avoidance group, to the group that got this intervention, as we think that they're going to have the greater risk. And then we're going to compare them in relation to the risk factor, the outcome, the response variable, how they call it. And that is whether or not they failed the oral food challenge. In other words, did they get the allergy? So did the peanut avoidant group, that's the first row, get the allergy? That's the first column. 36 individuals in the peanut avoidant group got the allergy out of 263 kids. So if you wanted to calculate the risk of getting the having the peanut allergy in the peanut avoidant group, that's 36 divided by 263. Now they're being compared against the group that got the intervention, the peanut consumption group, the 6 grams of peanuts per day. And only 5 of those kids developed the allergy out of 267. So if you if you want to know what that means in terms of strength of association, you would need to do the risk ratio. So you would do the calculation through 36 divided by 263, and then you would take 5 divided by 267, and that would give you the risk ratio, comparing the risk in the peanut avoidant group to the risk and divided by the risk in the peanut consumption group. So this is how we look at information in epidemiology. It's how we collect it. It's how we store the information. That is how we do the final analysis. So the first is a summary of the actual data. And the second is we take that data and we do something with it. We create 2x2 tables. We add up how many of those kids that were in the peanut avoidant group are there that also failed the allergy test. The second example they give is another example where they show how the data looks. They give more variables, but only for 4 people. And they just show 1, 2, 3, and then participant number 595. And they don't give that number 1, 2, 3 as if it's an identifier, but it would be in a data set. And so they're saying, okay, we have these rows of individuals, and we have information, and they're just showing 7 variables. We have information on sex, age, race, height, weight, something called ACTNR N3.R577X, and then something called NDRM.CH. Now, it's easy to look at these variables and say, okay, I think I know what sex, age, race, and height and weight mean. It looks like height is being measured in inches. I don't know what other races apart from Caucasians were considered, and I have no idea what those last 2 variables are because this is outside of my area of expertise. Now you're going to have that quite a bit in the AdHealth study, not because it's out of your area of expertise, but also because the variable names don't really make intuitive sense. And so that's where we go to the variable description. And in SPSS, that's going to be the variable view, and that's where it's a long list of variables, and you look over to the column called the label. So here they say the variable and they call it the description in SPSS. That column is described as the label. It's the same thing. So all of the variables that you imagine, sex, age, that is as you would expect. Race, they only have a limited a number of categories, and they're combining the concept of race and ethnicity, but it's recorded as African American, Caucasian, Asian, Hispanic, or other. They have height in inches, weight in pounds, and then they have other variables that relate to the genotype they're looking at, and then the outcome, which has to do with percent change in strength. So this has to do with their hypothesis. And then underneath, they clarify which are the numerical variables. So age, height, weight, and NDRM.CH are numerical variables. They take on numerical values. So in other words, you can add, subtract, take averages, and so that matters. So when in your assignment, you will be asked to give means and medians if it makes sense. So you will get that information, and you can get information on non-numerical variables. SPSS will give you a mean and a median, but it just doesn't mean anything. So age is a numerical variable, but it's also discrete because it has its numerical values that jump, so 1 year to the next year. Percentage change is continuous. It takes on any value within that range. So this is just an overview of the data, and this sort of links then to the different types of variables that will be in the next video. Thank you.